Hello everyone, I am Pawan Kumar Sak, PhD scholar from IIT Kanpur. I am the TA for the course of Elements of Solar Energy. Today I will take this discussion hour where I will discuss about the angles, different angles, and also if we would have some time, then we will say some derivatives. Okay. So in the last lecture I have discussed about the solar. Sorry. In the last lecture I have discussed about the solar time and standard time. Also, I have discussed the atmospheric attenuation, where we have seen that how the radiation affects because of the atmosphere. Okay, so there is one more question left in the last discussion hour. So today I will solve this problem and then we will see the different problems on the different angles. Okay. So the first problem is the clock time for Kolkata is decided by the solar time of Prayagraj, where longitude and the latitude is given. Clock time for Riyadh is decided by the solar time on the standard meridian of Saudi Arabia. When a clock at Kolkata reads 2 p.m., what will be the solar time for Riyadh? Also, it is given that neglect the correction introduced by the equation of time. So, in the last discussion hour, I have discussed that what is the solar time and what is standard time. So in this problem, it is given that when a clock at Kolkata reads 2 p.m. I have told that the clock time is nothing but just a standard time. Thus in the problem, it is given that Kolkata reads 2 p.m. as a clock time. So this 2 p.m. this is the standard time. Okay. Standard time for all over the country. Okay. So also we know that for India the standard time is decided based on the location Prayagraj. Okay. So this 2 p.m. will be the solar time for the Prayagraj also. Okay. So the next it is given that clock time for Riyadh is decided by the solar time on the standard meridian of Saudi Arabia. Okay. So also I want to discuss that this 25, the first coordinate that is given, this is latitude. The second one, this is longitude. Okay. Longitude and latitude. Okay. So as we know that now we have the standard time for the Prayagraj. So we can calculate the solar time for the Saudi Arabia. Okay. So the formula that I have used in the last class is given as the solar time is equal to standard time plus minus 4 longitude of standard minus longitude of local, where we want to calculate the solar time. Okay, plus E. This E is the equation of time. In the problem it is given that we can neglect this. So this will be the 0 for this problem. Okay. And in this formula I have also discussed that this plus minus sign for the eastern hemisphere it will be negative. Okay. Whereas for western hemisphere it will be positive. Okay. So now coming to our problem, both the locations like Saudi Arabia, that is 45 east, that is in the east, also our the standard location, that is Prayagraj, is in the east of the prime meridian. Okay, so the formula that for us will be the standard time minus 4 times longitude of standard minus longitude of local. Okay, this will be the solar time for Saudi Arabia. Okay, so now as we know that the standard time is the 2 p.m. Okay, minus 4 time longitude of the standard location, that is Prayagraj, is 82 east. Okay, so it will be 82 minus local that we are considering as Saudi Arabia. Okay, so for Saudi Arabia the longitude is given as 45, so 82 minus 45, this will be the in minutes. Okay, so it will be 2 p.m. minus, when you will solve this you will get, it will come out to 148 minutes. This 148 minutes we can write as 2 hours and 28 minutes. When we will subtract it by 2 p.m. then we will be able to find the solar time for Saudi Arabia will be the 11 a.m. and 32 minutes. Okay, now coming to the second location that is given as Riyadh, where we have to calculate the solar time. In the problem it is given that the clock time for Riyadh is decided by the solar time on the standard meridian of Saudi Arabia. So what will happen, that this solar time for Saudi Arabia, this will be the standard time for the Riyadh. Okay, so now if we want to calculate the solar time for the Riyadh, then we can write solar time for Riyadh will be the standard time minus 4 times longitude of standard minus longitude of local. So now here the longitude of standard, it will be for Saudi Arabia. Okay, because it is given in the problem that the solar time on the standard meridian of Saudi Arabia, that should be the taken as standard for Riyadh. Okay, also for Riyadh the longitude is given as 47 east. Okay, so both the coordinates in east, that's why I have taken as negative sign. Okay, so now the standard time for Riyadh is 11 a.m. 32 minutes. Okay, so 11 a.m. 32 minutes minus 4 times this standard longitude for Saudi Arabia is 45, and for the Riyadh it is 47. Okay, and this will be in minutes. So when we will solve this, then we will get 11 a.m. 32 minutes this, and it will be plus 8 minutes. So for solar time for Riyadh will be 11 a.m. and 40 minutes. Okay, so this will be the answer for our first problem. So if anyone has any doubt, then he can ask. Okay, so let's move to the next problem. So the second problem is the discuss the hour angle in a schematic diagram. So first we have to understand that what is hour angle and why we have needed this hour angle. So hour angle is just tell about the angular displacement of sun east or west of the local meridian due to the rotation of the earth. Let me write this. Okay, so the hour angle is just used for the calculation of time in terms of angular, in terms of angles. Okay, so as we know that our Earth revolves around its axis in 24 hours. So in 24 hours, Earth rotates 360 degree. So in 1 hour, it will rotate 15 degree. Okay, so our angle is connected with these phenomena that how much time, how much it is revolving. Okay, for particular time. Okay, so if we will see that we can say that the hour angle, it is also denoted as omega, or we can say W. Okay, so as we know that we consider that 12 hours days and 12 hours noon and 12 hours night in a day. Okay, so from this we can say that this hour angle value will vary between plus 180 degree to minus 180 degree. Okay, where this plus and minus sign is taken as for morning, that is before noon, omega is taken as negative. Okay, and for afternoon, omega is taken as positive. Okay, so suppose we want to calculate for a particular location the hour angle. Okay, and the time is given as suppose 3 p.m. Then someone is asking that what will be the hour time for that location. Okay, so for noon, okay, we consider that omega is 0. Okay, and after that as we will go towards the noon, then it will be added, and in the morning time it will be taken as negative. Okay, so for 3 p.m. it will be taken as 3 hours. Okay, and in 1 hour it rotates around 15 degree, so it will be 45 degree. So we will say that the hour angle will be 45 degree for 3 p.m. for a particular location. Okay, the similarly, if someone asks that what will be the hour angle for 10 a.m., then we will say that omega will be minus, because it is before noon. That's why I have taken negative sign. So minus 2 hours. This hour is calculated from the 12 p.m. noon. Okay. So omega will be minus 2 into 15. That will be minus 30 degree. Okay. So from this we have seen that we can easily calculate the hour angle if the time and for a particular location is given. Okay, so now we will see with this schematic diagram that what does this definition physically mean. Okay, that what is the angular displacement mean. Okay, I have taken a semi-hemisphere that represents the half part of the globe, and this is the north and south direction. Okay, and our sun ray is coming through this point. Okay, so this is our observer location and this is center. If we plot the projection of the sun ray and the observer location on the equatorial plane, then what we will find? Suppose this is IN. Okay, that is coming, and this is the point P. Okay, that is an arbitrary point. So this is the projection on the equatorial plane. Okay, let's it is P dash. Okay, so this is the projection of IN on the equatorial plane. Similarly, we can draw the projection of this observer location. Suppose it is O dash. Okay, So this is the projection of the observer on the equatorial plane. Okay, so then we can say that there is a angle between these projections on the equatorial plane. Okay, so this is nothing, just the our angle. Okay, also from the figure we can say that with the time, this projection of the sun ray, that is in, will change with the time. That is why the hour angle omega will change. And at on solar noon, this sun ray will be perpendicular. If we plot a horizontal plane on this pan, on this observer location, then we will find that on solar noon the sun ray is perpendicular to this location. Then we will be able to get the, then at the solar noon time, the projection of this in, okay, will be the same on this line CO dash. That is why we say that omega is 0 at solar noon. Okay, so from here we can say that our angle is an angle on the equatorial plane between the projection of CO and CP. Okay, that is CP dash and CO dash. Okay. Okay, so that's all I want to discuss for this hour angle. Okay, if anyone has any doubt, then he can ask.
Sir, could
Yeah.
you please plot this minus 180 degree and plus 180 degree on the diagram?
Yes. So, hello.
Yes, sir.
Could you just repeat your doubt?
Yes, sir. Could you please point the minus 180 and plus 180 on the diagram, the degree?
Yeah, yes. Okay. Then I'm getting. As I have told you that on solar noon, the sun ray will be perpendicular to this location O. Okay, and with the time it will be moving. That is why the hour angle will change. So from this figure we can see that this hour angle, okay, that will vary from this to this point. Also, the similarly it will happen in the opposite direction. Okay, so this is our 180 degree that I was saying.
Okay.
Okay, are you able to get your?
Yes, sir. Yes, sir. Sir, what is the significance of this hour angle? Sir, why we need to study this?
Yeah, that I have discussed that it signifies that how much the earth is rotating with the time. Okay, for a particular time, how much earth rotates. That is
Okay.
not a typical term like hour angle. As I have also show you that for a particular time it is very easy to calculate. It just tells about the angle, how much angle for a particular location the sun changes its location. Okay,
With respect to Earth, right?
with respect to
Earth.
sorry, I am not getting you.
With respect to Earth.
Yeah.
Okay.
With respect to any particular position. Okay.
Okay. Thank you.
Yeah. Okay, so can someone guess that what will be this angle? You can also write in chat box if you want. Okay, so I think okay, so this is nothing, just the declination angle. Okay. Also, if you want to tell you that what is altitude angle, then latitude and longitude, then you can easily get from this figure that this is the angle between the projection of any observer with on the equatorial plane. This angle is called the latitude angle. Okay, and if you want to find the longitude angle, then you will have required the prime meridian. Okay, suppose this is the prime meridian, and the when we will plot its projection on this equatorial plane, then suppose this is the projection of the prime meridian, then the angle between the projection of this observer with the prime meridian, this is phi. Okay, that is longitude. So as we know that this is our north and south direction, and these are our east and west direction. So the longitude we represent in terms of east and west. Okay, similarly we can say that this latitude angle that will vary from north pole towards the south pole. Okay, so it represents as n or s. Okay, that I have also written in the last problem as 25n and 82 east. Okay, so that's all I want to discuss with this figure. Now let's move to the next problem. Okay, so the next problem is find out the theoretical day length for Kanpur on 14th August 2022. So as I have discussed, that this is the latitude and this one is our longitude. So I hope that you have gone through the lectures, and you are aware the formula for calculation of this theoretical length. Okay, so the formula for this calculation is SP equal to 2 omega s by 15. Okay, where this 15 comes because the sun, because the earth revolves 15 degree in 1 hour. Okay, as I have told you that omega s is uh, used in terms of angle. That is why to convert this 2 omega s in terms of hour, we have divided it by 15. So this sp then we will be in hours. Okay, so now the question is that how we will calculate this omega s. Okay, so I hope that you have also seen this formula, that is omega s equal to cos inverse minus tan latitude dot length and declination angle. Okay, so for calculating this omega s, we have needed the latitude angle and the declination angle. In this problem, the declination has not been given directly. That's why we have to calculate this angle by using this day day. As we have know that declination angle depends only on the day. Okay, yeah, I hope that you have remembered this graph where you have seen that this is the curve. Okay, and this is the December, where you have seen that this delta angle changes between minus 23.45 to 23.45 throughout the year. Okay, so now our task is to calculate this declination angle on 14th August. Okay, so for 14th August, first we have to calculate the value of n. Okay, so January, February, March, August, 14th August. That's why this is 14. Jan 31, Feb 28. Okay, then we will sum all these days. Then we will find that the value of n is 226. Okay, so if we are able to get this n value, then we can easily calculate the declination angle that is given by this formula. Delta is equal to 23.45 sine 360 284 plus n divided by 365. Okay, if we will put this n value, if we will solve this, then we will find that the declination angle is comes out to be 14.108 degree. Okay. Also we can see from the figure that the peak, that is 23.45, occurs on this one is 21st June. Okay, so after that its value decreases and it comes to be 0 on 21st September. So between 21st June and 21st September, the values will be in between 23.45 and 0. So this value 14.108, that will be around this, and this time will be 14th August. Okay, so now we are able to find this declination angle, then we can calculate this day length. SP is equal to, no, first, sorry, I have to first calculate the omega s. Okay, from the formula that I have discussed, that omega s is equal to minus cos inverse minus k tan. The latitude value is given as 26 degree north. Okay, so minus tan 26 dot multiplied by tan declination angle, is that is 14.108 degree. When we will solve this, then we will find that this omega s value comes out to be 97.04 degree. Okay, so now it is easy to find the day length, that it is equal to 2 into 97.04 divided by 50. When we will solve this, we will find it at 12.94. Okay, so this is the day length. If we are talking in terms of maths, then we can easily leave it at 12.94. But in terms of days, we should we should solve this 0.94, as we cannot say that 12.94 hours. So this will be the 12 hour, and this 0.94 will be, when you will multiply it with 60, as we know that this 0.94 is in hour. If we will convert it in minutes, then we have to multiply it with 60. Then we will find that the day length will be 12 hours and 56 minutes. Okay, so this is the day length. It means when the sun rises and the sunset, this is the hour length in between the sunrise and sun hours. Okay, so also you can see that this omega is or the day length. The day length depends on the latitude, that is the location of the observer, and the declination angle. Further, the declination angle depends only on the day length. So for a particular location, the the day length varies with the day, every day, okay, throughout the year. So for different locations, there will be the different day length. Okay, so till now, if anyone has any doubt, then he can ask me. Okay, so let's move to the next problem, that is calculate the day length on May 13 and December 12 for a south facing surface tilted at an angle of 40 degree and located at New Delhi. Okay, so till now in the above problem, I have not discussed that the observer is like point observer, or as we know that when we are calculating all these terms for the instruments that we will use in the renewable energy source, as a renewable energy sources, okay, like PV panels. So it is not a point source. Okay, it will be a planar surface. Okay, so the surface may be some tilted with the horizontal plane, so that is given. So now how the tilt, as you can mm, imagine that this tilt maybe happen with the east-west direction or the similarly with the north and south direction. So in this problem, it is given that it is south facing surface. Okay, it means that this surface that we have considering in this problem is not tilted with the north or south direction. We have to consider the tilt angle only with the east or west direction. Okay, that we will see with the figure. Okay, so first I will show you that what does that surface facing tilted mean. Okay, so suppose this is the surface, this is the east west north. Okay, so I have considered a surface. Okay, that is not south facing. Okay, now what will happen? Okay, that I want to show you. Suppose this is the normal of this horizontal plane. Okay, then if we will project this on this horizontal, on the horizontal plane. Okay, then we will find that this is the projection of this. Suppose this is P, then this is P dash. Okay, this OP dash is the projection that is making angle with the south direction. Okay, so this angle is called the surface azimuth angle. Okay, and this plane is tilted at any angle beta. Okay, so now if we are saying, now you have to imagine that what I'm trying to say, that if the question is saying that the surface is south facing. Okay, then what will happen, that this normal projection, that is OP dash, if it is south facing, then this OP dash will lie on this OS, that is in the south direction. Okay, then this value AZS. Okay, so for south facing, this AZS value will be 0. That the question is trying to say. Okay, so if anyone has any doubt in this, then he can ask. Okay, so now move to the problem. It is given that it is tilted at an angle of 40 degree. Okay, so in the above problem, we have seen the formula. I think I should write this again. So the formula for the, we have to calculate the day length. Okay, we have written the formula for the omega s, that is cos inverse minus tan L dot tan delta. Okay, in this formula I have not taken any tilt angle for the surface. Now we have to see that if surface is tilted, then how the formula will change. Okay, so I am trying to show you with the figure. Suppose this is our surface. Nidharan is asking, sir, the word azimuth means. Okay, right now I'm not able to get your problem. Okay, Nidharan, I will try to give your answer in the next discussion hour. Okay, is that fine? Okay, fine. So let's see that what does this how this formula will change with the tilt angle. Okay, so suppose this is our horizontal plane on any surface. Okay, this is the horizontal plane. Then if we will connect it with the center of this earth, it will be the latitude of this location. Okay, now if we will see that suppose this is the any plane that is tilted with the horizontal with the angle beta. Okay, then what will happen? So from this figure we can see that if we plot one parallel surface with this tilted plane. Okay, this is tilted plane, this is our horizontal plane. Then we can find a point where this tilted plane will be the horizontal plane for any location. Okay, so I think I have to draw it again. This is horizontal plane, this is our tilted plane with the angle beta. Okay, then we can find any location on this surface where this tilted plane will be the horizontal plane. Okay, so suppose this is when we will plot a parallel line. Okay, then we will find that this plane will be the horizontal plane for this particular position. Okay, now we have what we have to calculate, that what will be the location or the coordinate for this location. So when you will solve, then you will be able to find that the location of this point will be the L minus beta. Okay, so now this is our horizontal plane. Okay, for our earth surface, and the above formula is valid for a horizontal plane. Now with this discussion we can say that for a tilted plane at an angle beta, the formula for omega s can be written as I have written omega s is equal to cos inverse minus tan. Now this L is the latitude of the horizontal plane. Now we have transform our location with this L minus beta location. So this latitude angle will be now substituted with L minus beta, whereas as we know that declination angle, that is delta, depends only on the number of day. Okay, so it will not affect with the location, so it will remain same. So now if we are able to get this formula, then we can easily calculate the day length for any tilted plane for different days. Okay, so suppose now we want to calculate it for 13th May. Okay, so first 13th May. Okay, so for 13th May the N will be Jan, Feb, April and May. Then this N will be 133. Okay, then we can easily calculate the declination angle as delta is equal to 23.45 sine of 360 to 84 plus n, that is 133 divided by 365. When you will solve this, you will find that delta value is 18.3. Okay, so if you are able to get this 18.3, then you can easily calculate the omega s, that will be the cos inverse of minus 10 L, that is latitude, for the location of New Delhi, that is given as 28. Okay, so 28 minus beta, beta is given as 40 degree. Okay, then dot 10 declination angle. Okay, when you will solve this, you will find that omega s comes out to be 85.97 degree. Okay, then we can calculate this day length, that is sp is equal to 2 omega s by 15, that will be the 2 into 85.97 by 15, that comes out to be 11.46. When you will convert it in hour and minute, then you will find that this is 11 hours and 27 minutes. Okay, so this is the first part for the 13th way. Similarly, we can solve this for December 12. Okay, so for December 12, the n value will be 365 minus 19 days that remains in a year. Okay, so it will be 346. Then you will use the formula that I have written above for delta, and you will find that this delta value comes out to be minus 23.18 degree. Okay, also now you can confirm your value of delta with the figure that I have shown you earlier. Okay, in this figure you know that the minimum value, that is minus 23.45, occur on 21st December. Okay, and now we are discussing for 12 December, that will be near to this 21st December. So the value should be near to minus 23.45 degree. Okay, so the same we have achieved, that is very few difference, as the days is remain only around 9 days for 21st December. Okay, so this is the value for the delta. Then we can solve for omega s, that will be cos inverse minus 10 28 L minus beta, that is fixed for a particular location. Okay, then 10 of delta, that is minus 23.18. Okay, when you will solve, you will find that omega s comes out to be 95.22 degree. Then you will be able to find the day length, that is sp equal to 2 omega s by 15, and you will find it as 12.7, that we can write as 12 hour and 42 minutes. Okay, so now I hope that you are able to find the day length also with the declination angle for any location and for any day. Okay, so till now, if anyone has any doubt, then we can ask. Okay, so let's move to the next problem that has been asked, that calculate the zenith angle at 4 p.m. solar time on 14th August at Kanpur, 26 degree north and 80 degree east. Okay, so I expect that you have gone through the lectures and you have aware with this formula, that is cos theta z equal to cos of latitude multiplied by cos of declination multiplied by cos of hour angle plus sine of latitude angle multiplied with sine of declination angle. Okay, so in this problem, this, as we know that this is our latitude, this is our longitude. Okay, in the north direction we consider it as positive, whereas in south direction we consider it as negative. Okay, so the L value will be our plus 26 degree. Okay, that is given in the problem. Also we have required to find the declination angle and the hour angle to calculate the zenith angle. Okay, so as the time is given, okay, 4 p.m. as I have discussed earlier, that with given time you can easily calculate the hour angle. So 4 p.m. the hour angle will be omega is equal to 4 hours after 12 noon. That is why I have multiplied 4 with the 15 degree. Okay, so omega will be our 60 degree. Okay, now we have required only the declination angle, that is delta. Okay, so for the 14th August, that is given in the problem. So for 14th August, n value, I think I have calculated it in earlier problem. Okay, so in this problem I have calculated n. So I'm just taking directly n as to 26. I'm not calculating it again. Okay, so the n value is 226, and the declination angle that I have also calculated in earlier problem. That is why I'm writing it directly. Okay, I'm writing once again the formula for this. Okay, 23.45 sine 360 38 oh, sorry 284 plus n divided by 365. Okay, when you will put the value of n, then you will find that this declination angle is delta is equal to 14.108 degree. Okay, now you have this declination angle, you have this hour angle value, and also you have this latitude value. Okay, so now you can easily calculate it as cos theta z will be the cos of latitude, that is 26 degree, multiplied by cos of declination angle, that is 14.108 degree, multiplied with cos of hour angle, that is 60 degree, plus sine of latitude multiplied with sine of declination angle. Okay, so when you will solve this, you will find it as 0.5427. Then you will take a inverse of cos, then you will find that this theta z value will be 57.13 angle. Okay, so now we have seen that we can easily calculate this zenith angle. Also, I want to show you that what does this zenith angle mean. Okay, so suppose this is any horizontal plane, and this is our north south, this is the vertical of this plane. Okay, and sun is at any particular position, that is like that, and sun ray is coming to this horizontal plane. Okay, then if we will draw its projection of this in on this horizontal plane, then we will find that this is the projection of in. Okay, then this projection makes the angle with the projection of its on the horizontal plane, that is called altitude angle, that is alpha. Okay, and this sun ray makes the angle with the vertical direction. This one is called the zenith angle. Okay, and the angle with the south direction that the projection of in makes is called the solar azimuth angle. Okay, so from the figure you can see that the altitude and zenith angle lies on a same plane, that is perpendicular to this horizontal plane, that you can say suppose this is a vertical plane. Okay, then this alpha and theta z, both angles lie on a same plane, and this az is in lies on a perpendicular plane to this vertical direction. Okay, so from this figure you can see that alpha plus theta z is pi by 2, that is 90 degree. Okay, so if we want to calculate the altitude angle for any particular location, then from the above formula we can say that we can put theta z as pi by 2 minus alpha. Then you can find that our formula comes out to be sin alpha is equal to cos L cos delta cos our angle plus sin latitude dot sin declination angle. Okay, so this is the formula to calculate the altitude angle directly. Also, if you have this zenith angle, then you can directly calculate alpha is equal to 90 degree minus 57.13 degree. That comes out to be 32.87 degree. Okay, so for this for this problem I have calculated both the zenith angle and altitude angle. Also I have shown you that what does this zenith angle and altitude angle mean in terms of this latitude and longitude in the formula. Okay, so now coming to the next problem. The question asks that find out the sunrise time for Kolkata in terms of solar time on 13th August. Okay, the day is given, that is 13th August, and the sunrise time. Okay, so the basically question from the if we are able to find the omega s, okay, then we can easily calculate the sunrise time by subtracting it with the solar time, that is 12 noon. Okay, so our task is to calculate this omega s. Okay, and this formula for this omega s I have shown you in the above problems also, that is omega s is equal to cos inverse minus k tan latitude dot tan multiplied by tan of declination angle if there is no tilt. Okay, for 13th August the n value will be uh, less than 1 from this above problem 14th August. So for 14th August the n value is 226. Okay, so for 13th August it will be 225. I'm not calculating it again and again, that is why I have taken it from above. Okay, so now if we have this n value, then we can easily calculate this declination angle that is given by this formula 23.45 sin 360 284 plus n divided by 365. When you will put this n value, then you will find that this delta will comes out to be this delta comes out to be 14.428 degree. Okay, now we can easily calculate omega s, that is omega is equal to my cos inverse of minus k tan latitude. Latitude is given as 23 degree north. Okay, so minus k tan 23 multiplied by tan of declination angle that we have calculated it at 14.428 degree. Okay, so when you will solve this, you will find that omega s comes out to be 96.27 degree. Okay, so now this omega s, that is our in terms of degree. Okay, we have to calculate the sunrise time, that is in terms of time, that is hour and minute. Okay, so we need to convert this omega s in terms of hour. So by dividing it by 15 degree, as we know that Earth revolves 15 degree in 1 hour, then it comes out to be 6.42 hour, or we can say 6 hour and 25 minutes. Okay. So now, as I have told you earlier, that the noon is considered at 12 p.m. Okay, and we have calculated that this omega s value is 6 hour and 25 minutes. So for calculating the sunrise time, what we will do? We will subtract this with 12 p.m. noon minus 6 hour and 25 minute, and it will come out to be 5 a.m. and 35 minutes. Okay, so now we have seen that for a particular location, that is Kolkata, on a particular day, at what time sun will rise, that comes out to be 5 a.m. and 35 minutes. Similarly, we can calculate the sunset time. Okay, what will be this? 12 p.m. plus omega s. Okay, that is 6 hour and 25 minutes. Then it comes out to be 6 p.m. and 25 minutes. Okay, and if someone asks you to calculate the day length, then you can directly calculate it by this 2 omega s. Now we know that this omega is in terms of hour, so it will come out to be 12.84 hour. Okay, or you can calculate with the time that how much time in between 5 a.m. 35 minutes and 6 p.m. 25 minutes. Okay, so as the time there is not enough time, so the next things I will discuss in the next discussion hour. So for today's discussion, if anyone has any doubt, then he can ask. Okay, so I think there is not any doubt, so I close this session. So thank you. Yeah, yeah, Satyavan.
So next discussion will be held on.
Next Saturday. Okay.
Okay, sir. Thanks.
Yeah. Okay. Thank you.
Hello, Pavan sir.
Yeah.
Sir, you are doing PhD in what area, sir?
Sorry.
You are doing PhD in what area, sir?
Fluid and thermal science.
Fluid and thermal science.
Yeah.
Okay, in IIT Kanpur.
Yes.
Okay, sir. Okay.
Okay. If you want to ask me anything about anything like for personal aspects, you can write me a mail. Okay. This is my sorry. This is my email ID also.
Okay, sir. Okay.
Yeah. Okay.
Okay,
So
sir. Thank you.
yeah. Thank you. Thank you very much.